we couldn't do it on any virtual function, just the first one. Okay, so probably the moment you've been waiting for, the demonstration of the IIS 5.1 remote exploit. A few words about this application, about this vulnerability. So this vulnerability was publicly known since December 05 and was fixed in the last patch Tuesday, which was on July 10th, 2007. So this emphasizes the fact that dangling pointers are usually, I don't want to say usually, but I see a lot of people that do not consider them as major security issues. It was said that this specific issue can only be used as is a DOS vulnerability, denial of service vulnerability. I personally think that denial of service vulnerabilities are very serious, but code execution vulnerabilities are much more serious. So it was fixed the last patch Tuesday. After we showed the newly discovered implications of this vulnerability, that it can be exploited for arbitrary code execution, Microsoft issued a patch very efficiently and fast. And enough talking about this application, I'm just going to show you the exploit. So here we have the IIS 5.1 web server. It is not patched, as you saw in the previous examples. It has nothing on it besides the ASPX I browsed to earlier. And this ASPX page could be any ASPX page. It has nothing special in it. So this is just a default installation of IIS 5.1. So once again, I'm going to make the application allocate the new object. Now I made it deallocate the object by sending the 3 requests. Now I'm just going to send a few more requests, and I'm going to use a tool called tamper data in order to do that. It's not really important that the technical details are inside the white paper that you can read. I'm just going to do some fast request sending, and the technical details can be read, and nothing really relevant to the presentation. So tamper data. So as you can see, the server is still up. We have a crash window, but as the server is still responding, as you can see, and this means that one of the threads of the application just crashed, but the application is still running if I do not click on any of these buttons. Now, when I shut down the server, you've been pwned by Watchfire, an IBM company. Okay, so this was my code. But you might still consider me a liar because I needed to run netstop W3 SVC on top of the vulnerable computer. And that is called a local exploit and not a remote exploit. I consider it to be a remote exploit because this code will run whenever the server stops. Every web server administrator sometimes reboots the server or shuts down the service of the server, and actually we get the same behavior when the server reboots. So we can just make the application make the dangling pointer point to our newly inserted object, and by that, when the application when the administrator reboots the web server, it will execute my newly inserted shellcode. In this remote exploit, I did not use any of the previously talked about exploitation techniques, because it was hard to implement this specifically remotely in this application. But this just show you that if you look deep enough inside the allocations of the specific application that you're trying to attack, you'll eventually find a way to exploit it. So what I'm saying, take dangling pointers very seriously. Okay, so what can we do in order to protect ourselves? There are some known protection mechanisms, such as the NX bit. The NX bit enables you to define some memory pages as executable and some as not executable. So when the application tries to execute the pages that are marked as non-executable, it will actually crash and not continue to execute it. So on each of the previously showed exploitation technique, the NX bit will actually save the vulnerable application from executing the inserted shellcode. A specific variation of the double reference exploitation technique can be done in order to exploit the systems that do use the NX bit protection mechanism. Next, we have the ASLR protection mechanism, which actually randomizes the memory layout of the application. And when it is used, you cannot reliably find static addresses that holds jump or call ECX or ECX inside the application memory. This protection mechanism can be overcome using the third exploitation technique, the look-aside exploitation technique, as I showed you earlier. The second a suggestion I have is virtual function table sanitization. Compilers can compile objects that, when executing virtual functions, sanitize the value of the virtual function table pointer and make sure that it does not point somewhere weird, and protect the application this way. And of course, the only true protection mechanism that can defend us is safe programming. We just need to develop safe software, because other protection mechanism can help and can be really efficient, but we will always find ways to overcome these protection mechanisms. Okay, so what did we have? First of all, we talked a bit about technical background. We talked about memory allocations, how it is implemented, about the look-aside list, and about object implementation, how does an object instance look like in the memory, inside the application's memory. Then we talked about three exploitation techniques: the double reference exploitation technique, the virtual function table exploitation technique, and the look-aside exploitation technique. Afterwards, I showed you a remote exploit of the Microsoft IIS 5.1 web server, and that was it. Another thing I want to say is that this research was performed on a specific kind of dangling pointers. There are other kinds of dangling pointers, and some research has been done in this direction in the community, the security community. And I think more research can be done, and other bugs might be proved as generally exploitable for arbitrary code execution. I think that every bug should be treated as every serious bug should be treated as major security issues, and developers do not need to wait until these kind of bugs are proved as exploitable. Another thing I want to say is just a few days ago I found actually another dangling pointer vulnerability, just like this one that I found, and I later found out that it was previously known since December 05. So I searched the web for this newly found vulnerability, and I found that this vulnerability was previously known also. I'm not going to talk about the details because we hadn't had a chance to contact the vendor yet, but this is interesting because this was too a dangling pointer problem that was known to the vendor, and he did not fix it. So this emphasizes the fact that sometimes dangling pointers are taken not very seriously and considered less dangerous than other bugs. Okay. More information can be found on the Watchfire website. You can find the updated white paper that we published with all the technical details inside it on this website. I also want to note Adi Shahrabani, who helped with this research and managed it. And that's it. Ask away. Any questions?
From a remediation perspective, would you consider just clearing out your pointer to make you safe? I mean, if you deallocated it, set it to null, you're okay, or do you need to do more than that?
So the question was whether a good remediation would be to null the pointer to the object after you deallocated the object. So you will not have a dangling pointer that points somewhere in the memory. It will have the value of null. Well, if I can make the application use this pointer as a pointer object, as an object pointer, excuse me, so I can still crash the application. I can still make this a denial of service situation because it will use null as a pointer to an object. I cannot think of a way now to exploit this kind of situation, but I would say I don't know how to exploit this kind of situation. It can improve your security, but you should not rely on this as a security measure. Yes?
First of all, I would imagine that these are all over the place in software, and just being, as you said, treated as if they're everyday old bugs. But I imagine they're probably everywhere. Have you been able to define, in some sense, certain patterns for how you define these kinds of issues? I mean, I imagine you're basically involving certain sequences of allocations and deallocations that are perhaps detectable in code.
So I guess everyone heard the question. He speaks very loud.
I have that habit. Wait till tomorrow.
Yeah. Okay, so actually the answer is that I do not have a specific pattern in order to detect this kind of vulnerabilities. But I said previously that this kind of vulnerabilities are sometimes hard to detect. Not every time when you deallocate an object, it gets inserted into the look-aside